Welcome to this session of Coffee in the Cloud, the Teams IT Pro Academy. I'm going to talk about media and Teams. This is part two, the media flow. My name is Martin Rias. I'm a Senior Program Manager in Teams Engineering. About this module, as always, you can find more modules like this, the decks and the recordings on aka.ms Teams Academy. If you want to provide feedback about this session or other sessions, please visit aka.ms/Teams community and use the IT Pro training label so that we can listen to your feedback. If you want to share feedback about features in Teams, please do this. Feedback is very important to us. Find us on aka.ms/Teams feedback and provide your feedback there about on existing items. Teams in Office 365 are cloud services and are evolving on a constant basis. To stay up to date with the latest changes, please visit aka.ms/Teams blog, where you can find all the news about features that have been shipped or will be shipping shortly. This is part two of this session. If you haven't seen this before, I strongly recommend that you visit aka.ms/why meetings are simple, where we're going to talk about how Teams helps you to deliver a really good media experience over existing infrastructure, and what the things are that you can do to further improve your experience. I'm going to assume that you've listened to that recording and that you are somewhat familiar with the concept of our Microsoft Global Network and the optimizations that you can apply to your own network to further improve the experience. Into this. After this session, you should be able to better explain how transferred relays, TRs, support delivering a really good performance for media calling and meetings, even under not so optimal media conditions. What controls you have and when you should use them to control the bandwidth consumption of the Teams clients, and what quality of service does to that effect, and how you can control this, and how to control this, as well as how you can leverage existing investments that you've made in your network. And then in the last part, I will also talk about how you can use media bypass to optimize your media flow and your end user experience when it comes to PSTN calls, or calls to the public switch telephony network. Let's start with TRs, transferred relays. Most of the times I'm going to use TR. We're really talking about the transferred relay. So the principle for connectivity and for transfer relays to that effect as well are that every time we talk about real-time media, about a call or about a meeting join scenario, we want to use a direct connection between these two endpoints, and we prefer UDP for this. As always, for real-time media, we really want to use UDP because that has the best characteristics when it comes to transport real-time media from point A to point B. However, not always we can establish a direct media connectivity using UDP. Maybe I'm behind a firewall, I'm behind a proxy, or some other network conditions prevent me to establish a direct connection to the other endpoint. And this is when concepts like the transferred relay will come into play to help us establish connectivity. The transferred relay in our case here really will act as a relay, as the name indicates, to allow the one person connecting to the transferred relay using UDP, using TCP, or even using HTTPS for proxy support, whereas the other part of the call can still establish a UDP connection. That's the high-level detail. I'm going to go into much more detail about this in the following slides here. Before we do talk about what the TR is and how it works and what protocols and ports are being used, just a quick recap on what this really is. I mean, for those of you that have dealt with OCS, Lync, and Skype on-prem environments, you're familiar with the concept of the edge server. Think of the transferred relay be the next iteration, the next variant, the next version of an edge server, but really born as a cloud service. So It's really there to provide the same, conceptually the same type of capabilities, ICE, stun and turn, those connectivity product establishment mechanisms. But the transport relay is really a cloud-born service. It was from the ground up designed and written as a cloud service. So we can make some really cool can leverage some really cool investments here that we can only do from a cloud service. One of those are, and I'm going to go into a little bit of implementation details here because I think it is quite important to understand. But also please be aware that those implementation details like the Anycast IP address and other technical concepts might change as we further evolve our implementation. At this point in time, the transport relays does use a concept of an Anycast IP address for service discovery. What is an Anycast IP address? Well, it is essentially a single IP address which is available and represented in all of our data centers. So a client can always talk to the same IP address. And it will find, through just IP routing and routing protocols, it will be redirected to the closest data center where this IP address or the service is available, so that we do not have any dependency on DNS or any other mechanism to find the locust, the closest data center, but we really just rely on IP routing here. The transport relay also allows to leverage, different UDP ports per service or per workload. We'll see this in a bit. In the previous deck, in the previous session, I did talk about the importance of local internet breakouts and how this can help you to deliver, a great service to your end users. And this is one of those examples where we are leveraging the local breakout, and by leveraging the local breakout, we can then talk to a local data center, and this is in the case of Teams as it is today, done by the Anycast IP address. So that's one of the examples why you really want to use a local internet breakout. Now let's go to this into a little bit more detail. So when we think about the usual call flow or the call establishment, what would happen is a client, when it starts or a media session, it will send a stun request. And each client in Teams today will always try to connect to this very IP address. This is the current Anycast IP address. So you would see the first request will always go to that IP address to UDP port 3478. It will then be routed to the next representation of this IP address in the closest data center where a transport relay is deployed. A random transport relay, which is available to service at this point in time, will pick up this request and will reply. And the reply will be a 401 unauthorized, and it will include a redirection to its own IP address, so to his unique IP address. So those TRs essentially listen to two IP addresses. Each TR listens to the global Anycast IP address. And then, of course, each transport relay machine or instance has its own unique IP address or individual IP address, IIP, I'll call it here. So the client talks to the Anycast IP, gets redirected to the individual IP, and from there on, the client will always talk to the TR using the individual IP. So the Anycast IP is really only used for service discovery. The actual communication later on is using the individual IP of the TR instance. And there, we would see what we know and love from ICE stun and turn. So we would go through the stun process of allocating ports, and depending on the configuration, there might be a redirect from UDP 3478 to 3479, and then we're going to do the stun auth and RTP and RTCP data flow from there on using the allocated ports. So quite a couple of years ago, we updated our documentation to indicate that customers are asked and are required to open UDP ports 3478 up to and including 3481. And the transport relay is one of those reasons why we are doing this. The transport relay, on the one side, if you look at the left-hand side, the communication between the client and his own transport relay. In the current configuration that we see here is always using 3478 for both discovery purposes as well as the actual transportation of media stream from the client to his own relay. So audio, video, and sharing will be sent over UDP 3478. And that is because in this particular tenant, the configuration for quality of service is turned to off. So this tenant has not configured quality of service, has not configured the service to do this. So which is why we are using 3478 from the client to his own relay. However, the transferred relay itself will always only offer those service-specific UDP ports. So 3479 is audio, 3480 is video, and 3481 is sharing. So the difference here is really communication from the client to his own TR, without QoS, is using 3478. The TR will always offer service-specific ports. Now, once the tenant admin turns on this setting, this toggle in the Teams admin portal to enable quality of service, a couple of things will happen. And one of those is that the communication from the client to his own transport relay will also use the service-specific UDP ports, which allows better identification of the traffic. But when we talk about QoS later on, we're going to talk about what you should and should not be using to identify traffic and configuring quality of service. But that is one of those scenarios where those different UDP ports are used based on workloads. What happens if UDP is blocked on one side? So again, I have the example here of a peer-to-peer call. It's me on the left-hand side. I'd like to call a colleague on the right-hand side, but I'm behind a setup and a firewall, a proxy, which is preventing me from using UDP 3478 outbound. What the transport relay is capable of doing is that it will fall back from UDP to TCP or even HTTPS with GET and PUT requests for discovery and the transportation of media. However, from the transport relay onwards, the transport relay itself will always and only offer UDP connection. So we do this to keep the non-optimal media path as short as possible, so that the transport relay acts really as a proxy or as a abstraction point, so that we, if one side of the leg cannot use UDP, that is fine. We're going to use TCP or even HTTPS, but from the transport relay onwards, it's always going to be UDP, so that we get the most optimal media transportation path. So that's really, a big change here from when we think about edge servers, where it really was about, when TCP was blocked, the entire call leg would be dragged down to TCP. In the case of the transport relay, even though it's a single call leg, we can, the TR has the capability to bridge between different communication protocols as needed, and will, quote unquote, upgrade communication always to UDP going forward. So we did talk a little bit about quality of service, and this particular setting you have in the admin portal. So when you go to the Teams admin portal, into meetings and the meeting settings, there is one toggle which allows you to say use quality of service. What this toggle does are two things. One, we've already seen, it will enable the workload-specific ports for the communication between the client and his own allocated transport relay. It will also instruct clients on iOS, on Android, and on macOS to mark outbound traffic with the appropriate DSCP marks, so that quality of service can be applied. In Windows, this is currently not possible, but there is work going on to enable this in Windows as well. And we'll be sharing updates as soon as this comes available. When you are thinking about quality of service implementation for a team setup, I would ask you to consider these scenarios that you are in. If you're coming from a Skype on-prem environment and you already have quality of service implemented, it's probably fairly easy for you to capitalize and reuse the existing quality of service investments that you made. There might be minor updates to the GPOs to make sure that the GPOs potentially also include the teams.exe executable to identify and mark traffic appropriately. But you also want to consider how to mark returning traffic, because traffic that is coming from the internet, you can no longer expect or rely on that the DSCP marks are still on those packets. So you need a strategy to remark traffic once it is inside your network again. And there you really want to use ACLs on the network, access controllers on the network, and identify traffic based on the client-side ports. So those are the ports that the client will be allocating. As seen here in the picture, 50,000 to 50,019 would be the client-side port for audio. 50,020 to 39 would be video, and so on. So those that would allow you to identify the traffic inside the network to apply quality of service. Now, I would ask you to consider your current network design and identify if there are a significant amount of wide area or MPLS circuits between your users and the internet breakout, because quality of service is really only there to make sure that traffic between your client and the internet breakout is not affected by any congestion that might happen. And usually that's really the wide area network links where we need quality of service to ensure quality of service. However, with networks evolving and local internet breakouts are getting more common, the necessity for quality of service and DSCP implementations, is probably going down. And that's one thing to consider. If you are in a situation where you have local internet breakouts for most or for all of your locations, quality of service might not be as important anymore. And it's called out here in this slide. Please do not use the destination ports for quality of service, because while enabling this flag will tell the transport relay to use those destination service workload specific destination ports, a transport relay might or might not be used, because if the client is able to hit directly the remote endpoint, the transport relay might not be used, in which case you might not know what the destination port is. And so for that reason, really don't use the destination ports on the transport relay side to identify traffic, but use the client side ports for to identify traffic. When we talk about quality of service, it's always about bandwidth and making sure that enough bandwidth is available to deliver a good enough end user experience. There might be scenarios where there is a need for you to limit the bandwidth consumption. Maybe there are sites where there's not enough bandwidth available, and you want to control the bandwidth that the Teams line will consume. And you have the ability. So in the admin portal, if you go to the meeting section, the meeting policies, in the audio and video section inside this policy, there is a media bitrate setting, which allows you to limit the maximum amount of bandwidth that a Teams client should be using for audio, video, and sharing together. So how to read this is essentially, if you were to configure the setting to, let's say, 1.5 megabit, you can expect that the client is still able to do a peer-to-peer video calling with a resolution of 1080p at 30 frames per second. If you were to limit the setting to, let's say, 500 kbps, it's reasonable to expect that the client will do 360p at 30 frames per second. The client will always try to work under those constraints and deliver the best possible experience. And so but this table should give you a bit of an overview. If you were to limit the bandwidth consumption, what is the end user experience that you most likely will be able to deliver? Be aware that specifically in sharing, you might see short peaks. In sharing scenarios, you might be seeing short peaks that go above and beyond this rate limit. However, the consumption on an average basis for a particular call or a session will be below the controlled limit here, the configured limit here. And as always, the media stack would optimize for the end user experience, so there is no direct control over, over codecs, resolution rates, etc. But it's really about the bandwidth consumption that you can control here. The link at the bottom of the document, prepare network, has further information on how to use those controls. So let's move on a little bit and talk about direct routing flows, connection to PSTN, SBCs, and how all of that works, because there are a couple of things that you might want to consider when configuring your network as well and your environment to deliver a great experience to your end users. So we're going to see this diagram in the next couple of slides, so let me briefly walk through this one. So at the bottom, we see the corporate network, and we have, inside the corporate network, we have a user with a Teams client who is inside the corporate network. And we have our certified session border controllers, which are used to, provide PSTN connectivity to Teams as a cloud service. In the middle, we have a user who is outside the corporate network, but somewhere on the internet. Maybe he's at home, maybe he's working from a coffee place, or some other internet-connected location. And then at the top, we have Office 365 as the cloud service with various components deployed here. And those components will change, and I'm going to talk about what those are. Now, first, talk about signaling, because signaling is an easy start here, because it's we'll see it's going to be straightforward. Because essentially, for signaling, each endpoint always needs to connect to the cloud service. So outside the user, signaling from a user point will always go to a component called call controller, which sits in Office 365/Teams. So the user from the internet will talk to the call controller, the user on the corporate network as well. Same concept here. When we think about signaling towards a session border controller, we need to talk SIP. So there's a component called SIP Proxy, the SP, which will do the protocol level translation between the Teams protocol, or the protocol layers are used inside Teams, and it's the SIP protocol that we use to communicate with SBCs. And from a signaling standpoint, that's really it. And then the SBC will establish the connection to the PSTN next hop, through a direct local internet, direct breakout, BRI, PRI, or maybe it would connect back to your SIP provider, or whatever your next hop might be. Signaling, relatively easy, relatively straightforward. Let's talk about media. For media, we have overall the same components, the same concepts. However, I've added two different components here, the TR, transferred relay, we talked about this already, and we have also the MP, the media processor. So think of it as a compute unit who does, and the MP is really there to do transcoding of media, or has transcoding capability. So it can receive a call from one codec and do transcoding to a different codec as needed. So really a computation device. So let's talk about this. The MPs do the transcoding, and MPs are located in our main regional data centers. So at this point, that's North America, Europe, APAC, and Japan data centers coming soon. Transferred relays are the relay components, and those are deployed in worldwide data centers, not only our main regional data centers. So we have more locations of TRs compared to media processors. So let's see how media flow is set up and will look like in a scenario where we do not use media bypass. So we have a user outside the corporate network. His media traffic needs to go to the media processor. So the traffic will be sent out towards Destiny to the MP. The traffic will use a little bit of internet until it hits our global network, the Microsoft network. And from there on, it will traverse over the Microsoft network onto the next media processor. So we are leveraging, most of the time, we are leveraging our, the Microsoft network. So we get the most optimal media experience here. The user from the internal network, it's actually a similar setup. So the user on the corporate network has to hit the media processor. So he would, egress from the corporate network to the internet, from the internet to traverse the internet and hit the Office 365 network to finally hit the MP. The MP is a Teams component, so all the great improvements we are doing in our own codecs and resiliency mechanisms can be applied here. So there's an advantage of doing this, because we can leverage the most optimal media stack here to deliver a great experience. The media processor now will apply transcoding as needed, and will use whatever codecs the SBC can support, do the transcoding, and will send back the traffic over the Office 365 network to the internet down to the SBC. So again, so that we only have a relatively short path over the actual internet, and still deliver a really good media quality here. And then from the SBC, the traffic would be sent to the PSTN next hop, to finally establish the call. So that, in a nutshell, is the setup for non-media bypass. Now we see for users who are on the internet, that's actually a pretty good experience. However, if we look about the user on the corporate network, this is not ideal, because it's unnecessary that the user who's sitting in the corporate network would relay all of his media flow through the cloud, break onto the internet, and send the traffic back and forth. That really doesn't really make a lot of sense. So let's take a look on what that look like when we enable media bypass in the same setup. So in this case, let's talk about a user who's internal to the network. So the user, we've changed the configuration, and we have enabled media bypass for our SBC here. What this would allow us to do is that the user can directly connect from where he is to the SBC. So we don't have to break out to the internet. We don't have to go to Office 365. At this point in time, it is required that the user can do hairpinning. So he would hit the public IP address configured for the session border controller. So that's the only catch here. You want to make sure that users inside your corporate network are allowed and able to hit the public IP address of your SBCs. But once that is done, it's a fairly direct connection, and we don't have to worry about codecs and transcoding, etc., because it's assumed that we have a pretty robust, pretty high quality network connection between those 2 endpoints in place. And from there on, the traffic would be hitting the PSTN next hop. If the connection between the user and the SBC cannot be established, we will then use the transport relay as a fallback. So which is why, if you want to use media bypass, we really want to make sure that hairpinning is allowed, because otherwise you actually can't leverage this concept at this point in time. So while this is great for the internal user, what would this do to the external users here? So let's look for him. So if the SBC and the potential firewall in front of the SBC and the connectivity is set up in such a way that the user on the internet can directly hit the SBC, he would do this. So again, we are trying to establish a direct connection, and this would happen. So the user on the internet would directly hit our session border controllers. Now, this is the most direct media path, but maybe not the most optimal one. Why is that? Well, because there it's really only the internet. There are no Office 365 components involved. There is no Office 365 network involved, which potentially can be a little bit of a challenge depending on where your users are and where the SBC is. So that is probably a scenario that you would want to avoid, because there is really no way for you to predict the end user experience, because it really just depends on the internet, and depending on the codecs that your SBC supports, sending VoIP traffic just randomly over the internet might or might not result in a, reasonably good end user experience. So what you can do there, and that is actually our recommendation in most cases, is that you would configure the SBCs and the connectivity of these SBCs in such a way that they cannot be reached from everybody on the internet, but is that the SBC, the public connectivity of the SBC is only available from Office 365 IP addresses. So let's see how that works. So let's imagine there is a firewall blocking rule in place or a routing limitation in place that a user from the internet cannot hit your SBC directly. What will happen? Well, we will be doing a fallback to the transport relay, because if I cannot establish direct connection between two endpoints, I will be using my transport relay. So this is what's going to happen. The user, instead of going direct, because direct connectivity cannot be established, the user would be hitting his transport relay. So a little bit of internet, a long path over, over our Office 365 network. So again, we get the optimized connectivity here. We would be hitting the transport relay, and then from the transport relay, we would be hitting the SBC again. And the advantage here is really that we essentially up level, if you want, the connection from just internet to a lot of Office 365 in the middle, because there is just a little bit of internet connectivity at the beginning, at the end of each call leg, but the majority of distance is expected to be traversed on the Microsoft network, which will deliver you a much better user experience. It's worth to note here and to call out that we are hitting the transport relay. We are not hitting the media processor. So the TR is just there to establish connectivity. The TR will not do any transcoding for you. So that's something to be aware. So let's summarize this real quick. From a media bypass point of view, a media processor will be used in the cases where media bypass is disabled or will not be used, because in that case, all calls will traverse via a media processor. Once media bypass is enabled on a SBC, a media processor will never be used. The media processor are deployed in our main regional data centers. A call which leverages when is a transport relay being used? Well, if a media bypass, if a call is enabled for media bypass, it might or might not use a transport relay. The advantage of TRs are that those are more, worldwide deployed to more locations. So it's very likely that there's a transport relay in relative short distance to where your users are. If there is any direct traffic between endpoints in the SBC, it will not hit any Office 365 network. However, traffic between endpoints and the transport relay will benefit from the Office 365 network. So the recommendation is, well, of course, it's hard to make a blanket recommendation that fits each and every deployment scenario. So you really want to think about how many SBCs do you have? Do you have SBCs in each and every site, or do you only have a few SBCs in many locations? What is the proximity of your users to the TRs, as far as you know? But the general rule of thumb is, consider this as a starting point for your design and for your implementation. For internal endpoints, you want to make sure that internal endpoints can leverage media bypass, and that there is that the setup, the network and everything is set up in such a way that internal endpoints are able to hit the SBC directly using media bypass. The rule of thumb for external endpoints is that we would recommend considering you to block connectivity from the internet and only allow connections to the SBC from our Office 365 IP address ranges. And those are published on the documentation page for direct routing. And the intent here is really to minimize, using connections that only hit the internet but don't touch our own infrastructure. Because at the time you hit our infrastructure, we have much better control over the traffic, and we can, do as best as we can to improve the end user experience here. So we talked about direct routing and media bypass. Now, what we talked so far about requires the SBC to be directly internet connected. Now, we realize that there are scenarios where this might not be an option or might be too complicated. I mean, if you think about, a large multinational deployment, tens or maybe hundreds of SBCs, it might not be feasible or actually doable to connect each of and every them SBCs to the internet. But you still want to make and receive calls. So for this scenario and for a couple of other scenarios, we've developed a feature, a component called local media optimization. I'll be talking about this. Everything we talked about in terms of, media bypass and the principles of connectivity, the transport relay for external users, all of those apply here as well. So keep that in mind. Let's talk about local media optimization and what this really is. So when we think about local media optimization, what is this really about? So here in this chart, you'll see a setup where we have, what we would call a central site in Singapore, and we have downstream sites. So the central site in Singapore is what we would call has a centralized proxy, SBC. So the proxy SBC is an SBC that essentially has two legs. One leg is connected to the internet, and we have public IP addresses there. The second leg of the SBC is, facing towards inside your corporate network and has, a private IP address that is reachable inside your corporate network only. In this same setup, we also have a site Vietnam here. This site has what we would call a downstream SBC or a downstream local SBC. This SBC is has only an internal IP address. So it is not connected to the internet directly, but it only has, a private internal IP address so that it can talk to clients and endpoints inside your corporate network, but is not reachable directly from the outside. And the intent here is really to deliver you a setup where media stays local whenever possible in each of those scenarios. In this session, I will be focusing really around the media flow elements. If you want to learn more about how to configure media optimization, please go to akms/Teams Academy and find the direct routing decks and the direct routing sessions where we talk about in depth about the configuration elements of local media optimization. Why do you want local media optimization? Well, because like I said, maybe you have a need that not every SBC can or should be internet facing. You don't have IP addresses there. You don't have, the right network equipment or other reasons that, would just, prevent you from connecting them. And this is what local media optimization really does. So the downstream SBCs would leverage the central internet connected SBC for the signaling and perhaps the media layer from it to the Microsoft service. However, you can configure the setup in such a way that media will stay local. And what local really means is what we're going to talk about here. Again, it's important to call out that this does require a little bit of configuration. So if you're not yet quite familiar with this, I really encourage you to go to our Academy page and go through the direct routing decks and sessions there to understand all the concepts here that are required to configure this. Let's start with the first scenario. This chart, well, this diagram might look familiar. I've updated this a little bit and I've added, additional sites here. So we will start with a simple setup where we have our central site in Singapore, where we have our proxy SBC. Again, remember the proxy SBC is the SBC that's connected to the internet. And we have a downstream SBC in Vietnam. And that one has only an internal IP address. In our case here, the user is configured or is dialing a number that is configured to use the SBC and the PSTN breakout in Vietnam. The user is outside the corporate network, so let's see how that works. So the first step is for local media optimization. The service does something where we would look up and try to identify whether the user is inside or outside the corporate network. And we do this by looking at the public IP address that we see from the client connecting to the service based on the signaling path. So we take the public IP address as the service sees the user and would compare this public IP address, or in the context of local media optimization, we would call this a trusted IP address. We compare this trusted IP address to those IP addresses that are configured for your network. And because the client is coming from outside the environment, we recognize this user to be outside of the network. Now, because you have to configure those sites, the user could be outside the corporate network, or the user could be coming from a site that hasn't been included in your configuration. So he actually could be inside the network, but he's just recognized to be outside because the IP address is not known. But in either case, the service is not able to confirm his location to be outside of the corporate network. So what will happen in this case is the client will be given the public IP address of the SBC and will then connect to the public SBC of the SBC directly, or because in this case we followed our configuration guidance here, and we can't hit this IP directly, so the user will connect via the transfer relay to the SBC. So that's so far so good. Now through the configuration that you would apply, we inject an additional header here that would instruct the proxy SBC that this connection actually needs to go to a specific downstream SBC. And so the proxy SBC would forward this call to the downstream SBC. Our call is established, and we can have a call. So that's the scenario. I'm outside the office, but I want to use a downstream SBC. Again, key here is the trusted IP address, because this is really the differentiator to help us identify whether the user is inside or outside the corporate network. Let's take this a step further. I've added a third site into the mix here. Again, we have our central site Singapore with the internet connected proxy SBC. We have a branch site in Vietnam where we have a downstream SBC. This downstream SBC is configured for bypass mode always, so it's configured to always bypass. And then we have a branch site in Indonesia, which does not have any SBC at all. And I have a user in Indonesia that wants to place a call using the downstream SBC. So how would that work? What's going to happen? Well, same concept as in the previous slide. First, the service will confirm whether the user is inside or outside the corporate network. In our case, the user is coming from a known trusted IP address, from a known public IP address. So this IP address matches actually the one that is configured for the site Indonesia. So the service knows this user is inside the corporate network. The next step, the service will look up the configuration of the SBC, of the path that's taken. In our case, the bypass mode is set to always. So if a user is inside the corporate network, he should always connect to the SBC directly. And well, that's what's going to happen. The user is, establishing direct connectivity to the SBC, and the SBC will connect the call to the public network, and the call will take place. So that's a good scenario, a good setup if you have good connectivity between these two sites, and the call will take a local route without needing to detour over any other SBC. In this scenario, same setup: Singapore, Vietnam, Indonesia. However, in this case, the connectivity between the site Indonesia and Vietnam is such way that we really don't want to have any real-time media traversing directly from Indonesia to Vietnam, because this link is just not doesn't provide the right quality that we want to achieve here. But actually, the connectivity from the site Indonesia to the Singapore side, as well as from Vietnam to Singapore side, branch to central site connectivity, hub and spoke type connectivity is actually good and can be used to support media. So how would that work out? In principle, the same concept applies. First, the user is validated whether he is inside or outside the corporate office by looking at the trusted IP address. In our case, trusted IP address is known, so he's inside the corporate office. Next step is we are validating whether the SBC that was chosen for his call is configured for media bypass. In our case, it is. However, the bypass mode is configured for only for local users. So connectivity to that SBC is only allowed for users who are confirmed to be inside the site Vietnam. In our case, the user is inside the office. However, his IP address does match to the site Indonesia. So the user is assigned to the site Indonesia, and that's a different site than Vietnam. So direct connectivity is not allowed. What will happen in this case is the user will connect to the internal interface of the Proxy SBC, and then the Proxy SBC will forward the connection to the downstream SBC. So we're, relaying the traffic over the internal interface of the Proxy SBC to establish this call out to the public network. Last setup here, what if the user is inside the Vietnam side? Well, same concepts apply. We confirm the user is inside the corporate network. No trusted IP address. Yes, he is. We're gonna check that. Second, we will check whether the user is using an SBC and what the bypass mode for the SBC is. The SBC is configured only for local users. So now we also have to check whether the user is inside the same network. In our case, yes, he is, because his internal IP address matches the internal subnet that is configured for the site Vietnam. So he'll be able to talk to the SBC directly and place the outbound call. So in summary, the trusted IPs or the public IP addresses are really there to confirm whether a user is inside or outside the corporate network. Remember this, that a user can be identified as outside the network because his public IP address might not be configured for the in your environment. So that's something to keep in mind. When we talk about the public IP addresses or trusted IP addresses, it's always based on the signaling path, on the HTTPS signaling path, because we need this information at the time when making the call. We just can't wait for media establishment, but we need this information earlier. So it's always about the signaling path. Also, only once a user is confirmed to be inside the corporate office, based on trusted IPs, he will be mapped to a site. So you do not have to worry about overlapping IP address ranges with, your private IP addresses at home or at a coffee place or some other random location. You need to be behind, a known trusted IP address to be able to map to a site. If the SBC route that is being identified contains an SBC which is configured only for local users, the site that the user has been identified as needs to match the site of the SBC. So in our example, only a user that is inside the site Vietnam with SBC configured for that bypass mode is able to leverage this SBC directly. All other connections will be relayed via the central proxy SBC. Users inside the corporate network will connect to the internal interface of your proxy SBC. So that's something to keep in mind here as well, because the proxy SBC actually has two IP addresses or two interfaces, that you have this flexibility here, to use the connection there. What have we talked about? What are the key learnings? So the transport relays or TRs support in delivering a good performance for real-time media under suboptimal conditions. So we talked about UDP, that we want to use direct UDP connection, and how a TR can be used in scenarios where UDP cannot be established, and that we use TCP or even HTTPS, but then that from the transport relay onwards, it will always be UDP. We also talked about that a TR can be used, but must not be used. We try to establish direct connectivity, and a TR is only a fallback. For media bypass, consider consider your scenario, consider your environment. As a starting point, as a rule of thumb, allow direct connectivity between SBCs and users internally, but consider blocking traffic from the internet to the SBCs, to essentially force traffic over our own infrastructure, over Microsoft's infrastructure. With that, thank you for listening in. I'm looking forward for the next session.